Physics chapter 28 theory video 3. So we are going to discuss about the threshold frequency and wavelength. So in the earlier practical we discussed how the ultraviolet radiation can remove electrons from the surface of a metal. So we discussed that if it is blocked by a glass, then it would not be able to release it, because still the light would be reaching it, but not the um, not enough. There wouldn't be enough frequency, that is the ultraviolet radiation does not reach with high frequency. So we understood that the minimum amount of frequency that is required to remove these electrons is referred to as the threshold frequency. So the minimum amount of frequency that is required. Then we know that C is equal to F lambda. So that means the threshold frequency should have the equivalent longest wavelength for that electron to be removed. That is called the threshold wavelength. So that is defined as the longest wave, that is the threshold wavelength is the longest wavelength of the electromagnetic radiation that would eject electrons from the surface of a metal. Remember these as just stories. You don't have to go into very much detail into this. So they had some trouble because bright light with lower frequency had no effect, but ultraviolet rays, which did not have any much light to see, had a greater effect on that. So Albert Einstein developed a theory where he suggested that a photon reaching the electrons on the surface of the metal is actually is like a energy well. The electrons are like in an energy well. So the photon needs to have energy that the photon will, one single photon will interact with one single electron, and it should be able to give that energy to the photon's energy, entire amount of, because this is a packet of energy, that the whole lot of energy will be transferred to the electron, and the photon does not exist anymore. So all the energy has been transferred. If that energy is able to overcome the minimum energy required to escape the surface, or jump out of that energy well, then it can reach. If it is just reaching out, if it is just about reaching out out of the well, then that energy is referred to as the threshold wavelength and threshold energy, or threshold frequency. So that is what you need to understand. So when ultraviolet radiation hits, you can see onto the zinc plate, electrons break free. So that happens because of this. So when the energy is transferred to this well, this electron HF, the photon transfers energy. So that will be taken up by one electron, and it escapes. So this is the energy well. So this amount of energy is what we refer to as phi, or the amount of energy that is required for this to escape. So that energy will be given by the photon. I hope it makes sense. So this minimum amount of energy phi is defined by the work energy function, or the work function of a metal, that is defined as the minimum amount of energy required by an electron to escape its surface. So that is the work function. Now the reason why it is needed is, now as Einstein explained that the electrons are electrons are there on the surface which are not really attached to a single atom. That is because they are free electrons which carry the which can carry the charge as well. So these are attracted by electrostatic attraction. There are electrostatic forces between positive metal ions. So that attraction needs to be overcome. So that is the reason why energy is needed for these to escape. I hope you understood. So when Einstein suggested also that the photons do not interact with all the electrons, but rather it would interact with only one. So based on this, there are some rules that have been developed for the photoelectric effect. Number one is electrons from the surface of the metal are removed, not from the interior. Then only a single photon can interact. The single photon can interact only with a single electron. That is, one-to-one interaction is there. Then the surface electron is instantly removed from the metal surface when the photon, the incident photon, that is the photon that interacts with it, has either equal or more than the work function of the metal. So you can remember now the work function is the minimum amount of energy that is needed by an electron on the surface to escape. So if the frequency of the incident radiation is greater than or equal to the threshold frequency of the metal, or the wavelength is less than or equal to. So you have to remember here the threshold frequency. So the frequency should be greater or equal to the threshold frequency. The wavelength should be either less than or the highest, or the less than or equal to the threshold wavelength. If the wavelength is higher, then the frequency would reduce and and it would not have the sufficient amount of energy. So those things you must understand. Then there should be a conservation of energy when the photon interacts with the electron. That means the entire amount of energy should be either given to the electron, or some of that should be wasted as heat energy. So it should be it is a law, it is a rule. So if you increase the intensity of the incident radiation, it will not still release any electron, because the frequency is less than the threshold frequency. So the intensity of the incident radiation is directly proportional to the rate at which photons arrive at the plate. So intensity is directly proportional to the rate at which photons arrive at the plate, but it would still have the same amount of energy, and that is going to be less than the work function. If it is less than the work function, then it cannot, whatever the intensity it is not going to release any electrons. So the photoelectric effect will not come about if they do not have the sufficient frequency, or if they exceed the threshold wavelength. I hope you understand that. Now photoelectric experiments that have been carried out have a certain kinetic energies up to some maximum value, Ke max. Electrons that are released will have a certain maximum kinetic energy. So the fastest moving electron, so the reason is this. Now just imagine there are two objects attached to the table, right? Two objects that are attached to the table. What you do is you hit these two objects. One object is tightly glued onto the surface. The other one is not glued at all, or loosely held. Then when you hit one of it will actually fly off with a higher kinetic energy. But the other one, some of the energy that you provide, you hit at the same rate, same frequency or same energy. But the second one some of that energy will be used to remove that. So as a result, it would have lesser kinetic energy, and the same thing happens here. So if a single photon interacts with a single surface electron, in freeing it, the energy of the photon is equal to the work function plus maximum kinetic energy of the electron. So that is something that you need to remember. So as a result, you will be able to get the velocity of the resulting this thing. Then from the energy of the photon, you have to subtract phi. That is the minimum amount of energy needed for the electron to escape should be subtracted. I hope that makes sense. So the equation is energy of the photon equals work function plus maximum kinetic energy of the electron. Now HF is the energy of the photon, phi is the work function of the metal, and half mv max squared is the maximum kinetic energy of the emitted photoelectron. So this is referred to as the photoelectric equation, and can be written as Hc upon lambda equals phi plus half mv max squared. So that is another both of these equations you must understand. So we start with the photon of energy HF. It is absorbed completely by an electron. Some of the energy, phi, is used to escape from the metal. The rest remains as kinetic energy of the electron. If the photon is absorbed by an electron that is lower in the energy well, the escaping electron will have less kinetic energy according to this diagram. As you can see, so these trapped electrons at the bottom, they would have lesser kinetic energy. They are trapped. So this would, as you can see here, this electron is coming from here. This photon hits this point. So it needs more phi. Along with phi, there is some more energy required to escape this part. I hope it makes sense. Then when if the incident radiation has a frequency equal to the threshold frequency of the metal, then kinetic energy is going to be zero. So because it is just enough to escape the minimum, then there won't be anything left. So that means in this equation, the amount of energy that is contained, the energy of the electron, is equal to phi. So that means if they are equal, this has to be zero. Kinetic energy should be zero, right? You understand that, right? So what happens is, apologies. What happens is the electron, then the photoelectric equation is going to be HFO is going to be phi, that is equal to phi. Because the threshold frequency FO is given by the expression phi upon H, we can get threshold wavelength is given by the expression lambda O equals Hc upon phi. We can have a relationship with all of these things. Then if it is less than the threshold frequency, the photon will give its energy to the electron, but the electron can't escape from the energy well. So that means the positive metal ions keep them attracted. It still has energy, but it cannot escape. So it will appear as kinetic energy of the electrons. So this kinetic energy will make it move faster. It will collide with the positive ions, and they will lose the lose the energy. So this energy will be lost as heat energy, and that will absorb that energy. That is the reason why now you know that if you keep a metal plate close to a table lamp, it gets hot. That is because of that. That is because the metal plate, it absorbs that. So as you can understand how these things are interconnected. So different metals have, like I said earlier, the threshold frequency will depend on the metal. So different metals have different threshold frequencies and have different work functions. For example, alkali metals such as sodium, potassium and rubidium, their frequencies are in the visible region of the electromagnetic spectrum. But in zinc, they are more tightly bound with the metal, so it is frequency is in the ultraviolet region of the spectrum. So that means alkali metal, potassium and rubidium, they are in the electromagnetic spectrum. So any radiation that comes in the electromagnetic radiation and above will be able to release the electrons in it. But in zinc, it would need the ultraviolet region waves. So the summary of photoelectric effect is emission of electrons happen as soon as the electromagnetic radiation is incident on the plate. So the comment is a single photon interacts with a single electron. If the energy of the photon is equal to or greater than the work function of the metal, the electron will be ejected instantaneously. It might have low intensity or weak low intensity electromagnetic radiation. So that means the rate is lesser, the photon rate is lesser, but still the high energy photons would be coming because the photon the energy of the photon depends on the frequency of the wavelength, not the intensity. So if the energy contained in the photon is equal to or higher than the work function, the electron will be ejected. So low intensity means it is coming at a lesser rate. So as a result, it doesn't actually related to the emission of the electrons in any way other than the electron emission is also going to be lesser because the photons are going to come at a lesser rate. Then increasing intensity of electromagnetic radiation would increase rate at which electrons have metal. Increasing intensity of electromagnetic radiation increases rate at which electrons leave metal. So that means that is obvious. If you greater intensity means greater rate of photons, the rate of photons arriving the metal surface is higher. So if the electrons are collected as part of an external circuit, so there would be these electrons would be kind of pre-arranged to leave kind of. So then the photoelectric current would be directly proportional to the intensity of the incident radiation. So this is actually not something that is very important, but try to remember that as well. Then intensity, if you increase the intensity, that has no effect on the kinetic energies of the electrons because it simply means that there are more photons coming and interacting with electrons. That's it. So the electrons can't have more kinetic energy because it is the same level of photons. Then minimum threshold of frequency is needed for the emission of electrons. So they have to overcome that phi or the energy well. So it should be either they should either have a frequency equal or higher than the threshold frequency. Then if you increase the frequency of the electromagnetic radiation, that increases the maximum kinetic energy of electrons because after reducing the phi amount of energy required for the work function, the remaining energy would be used as would be converted into kinetic energy. Kinetic energy max is equal to HF minus phi. So this is the this is the understanding. I hope you understood. If you did not, please ask questions. Now let's write down a note and then move on to the questions. Write down threshold frequency and wavelength. The minimum frequency that an incident radiation must have in order to release electrons from the metal is known as threshold frequency. This is a property of metals, and different metals have different threshold frequencies. Because C is equal to F lambda, the threshold frequency have an equivalent longest wavelength for the removal of electron, and this is called the threshold wavelength. So you need to remember that if the wavelength is that highest point or lesser, then it can release the electron. The minimum amount of energy that is required for an electron to escape the surface of the metal is known as work function energy, or the work function of that metal. This is the energy that the electron needs to overcome the attractions by the electrostatic forces of the metal ions. Einstein suggested that a single photon interacts with a single electron and transfers the energy to it. Following rules are identified in relation to photoelectric effect. Following rules are identified in relation to photoelectric effect. Number 1, electrons from the surface of the metal are removed. Number 2, a single photon can only interact and exchange energy with a single electron if the photon is from a radiation higher than or equal to threshold frequency, or equal or less than threshold wavelength, the surface electron will have sufficient energy to escape and will be removed instantaneously. Next one, energy is conserved when a photon interacts with an electron, and increase in the intensity of the incident radiation does not release electrons if its frequency is less than the threshold frequency. Leave a line and write, put a star and write down. Intensity is the rate at which photons arrive at the place. It does not increase the energy content of the photon. Einstein suggested the following photoelectric equation where he explained that the maximum kinetic energy of an electron is the result of energy of result of the work function removed from the energy of photon. So there are two equations. You need to write these two. HF equals phi plus half mv max squared, or Hc upon lambda equals phi plus half mv max squared. In the above equation, a photon has energy HF. It is absorbed by an electron. Part of it is used to escape from the metal phi. The rest would provide kinetic energy to the electron. Leave a line and write. If the photon is absorbed by an electron lower in the energy well, the escaping electron will have less kinetic energy than kinetic energy max, because it is not at the surface, a little below. When the leave a line and write, when the incident radiation has frequency equal to the threshold frequency, the kinetic energy of the electron would be 0. That is HFO equals phi. Then threshold frequency is FO equals phi upon H, and threshold wavelength lambda O equals Hc upon phi. Leave a line and write. If the incident radiation has less frequency than threshold frequency, still the photon will give the energy, but the electron would not be able to escape. That energy would be used as kinetic energy, and when the electron collides with the surrounding positive ions, energy would be lost as heat energy. Metals such as alkali metals, sodium, potassium, have a lower threshold frequencies in visible region of the electromagnetic spectrum, but metals such as zinc would have higher threshold frequencies in ultraviolet region of the spectrum. Please draw this diagram 28.10. You will be able to understand that, and then table 28.4 summary also you must write down, and then after that you will have to move to question number 10, 11, 12, 13. If you have any doubts, please ask. If you have doubts, ask. If you don't have doubts, if you understood everything in detail, please answer the questions. Make sure to write this chart down, because that is the summary of this, and there will be questions asked from this part of the lesson.